Hi, my name is Isabella Formica, and I'm in Lab 2 on Tuesday mornings with Dr. Jean. Today I'll be sharing the Experiment 2 lab report. Figure 1 reaction scheme. By adding copper to nitric acid, you get copper nitrite and nitrogen dioxide, and during this stage a brown gas appears and at the bottom is quite red. Next we add sodium hydroxide to get copper 2 hydroxide and sodium nitrate, and this forms at first a clearish light blue color, and it starts to thicken almost like a gelatin, and eventually develops into a darker blue, almost a laundry detergent like. Next, by adding heat, we have water and copper 2 oxide, and the color becomes a lot darker, almost black. There's about some powder at the bottom. Eventually black flakes start to form, and there's a small film on the top, and eventually also turns completely black. Next, by adding sulfuric acid, you get water and copper 2 sulfate. And at this stage, the black turns to a very light blue color and all of the particles disappear. Next, by adding zinc, you get zinc and dihydrogen, and over here you get zinc sulfate, and a clear gas appeared, and eventually you go back to solid copper. For my results 1 table, my initial mass of the copper was 0.511 grams. For the mass of the evaporating dish was 32.11 grams. For the mass of the evaporating dish and the recovered copper, I got 32.81 grams, and the mass of the recovered copper would be 0.7 grams. My percent yield was 137.3%, and to figure out the percent yield, I did the recovered copper, which is 0.7 grams, divided by the initial mass of the copper, which was 0.151 grams, times 100 to get my 137.3%. For my results, reaction, and observations chart, when nitric acid was added, the observations were a brown gas appeared, red at the bottom of the beaker. When sodium hydroxide was added, the observations were a clearish to light blue color. It felt almost like a gelatin type. Then it eventually turned light blue and looked like a laundry detergent. When the solution was heated, the observations were the colors got darker, turned to a black shade. Black flakes appeared, became more like a liquid, and it turned completely black. When sulfuric acid was added, the observations were it turned to a light blue color and the particles had disappeared. When zinc was added, the observation was a clear gas was added. For the discussion, question number 1, experimental error. An experimental error that could happen with a percent yield higher than 100% could be that not all of the water was evaporated out. The final copper stage could be more dense due to the water buildup, to the possible water buildup. An experimental error that could happen with a percent yield lower than 100% could happen while decanting the liquid out. It is next to impossible for all of the liquid to come out without some of the particles coming out as well. For discussion question number 2, no, I do not think that the final substance is pure copper because at the end of the cycle, zinc was added, as shown right here and here. For discussion question number 3, according to the Copper Development Association, 7 of copper's properties include melting point is 1,083 degrees Celsius, boiling point is 2,562 degrees Celsius, magnetic state is diamagnetic, the atomic number is 29, the atomic weight is 63.546, its valence states are 2 and 1, its heat of fusion is 13.26 kilojoules per molecule. Discussion question number 4, objectivity. For the purpose of their website is to keep other scientists and researchers updated on chemical development, focusing mostly on copper. The authors want to accomplish is getting the information about copper out there. This affects my presentation because the properties that I found, like the melting point and the boiling point, were used several times from turning from a liquid solid to gas. In our project, I would not say that there is any type of big bias towards this. I'd say that they are a well-rounded source and all of the information given has been found as facts. Part 2 of discussion question number 4, currency. Online it says that the Copper Development Association was updated at the beginning of September 2019, so about within the last week. Everything is currently up to date and it has not been superseded. Yes, I would say that the information on the website is related to my topic and to my assignment by showing different aspects of that copper has and the properties in question 3. The intended audience, I would have to say, is anyone looking for quality science work. Yes, I would also agree that it is at an appropriate level. There's many different scientists and researchers involved on this website. And the information, I would say, is complete. It has to do all with copper, which I find very neat and interesting, which they have so many different links and options to learn more about copper and really no other element or anything as it is, and I think that's very interesting itself. For discussion question number 5, I would research for number 3 to test whether or not the copper is pure or not. I would use its melting point as a reference to see whether or not, if anything was in there. Before hitting its melting point, another substance could possibly melt, or after the copper's melted, to see if the substance was still a solid and left behind. And last, my references.